Good afternoon. The title of the presentation is Wavelength and Palladium Thickness Optimization for Surface Plasma Resonance-based Hydrogen Sensors. This work is part of the thesis dissertation of Gustavo Cavalcanti under my guidance and has the collaboration of Professor Antônio Azevedo from the Physics Department at Federal University of Pernambuco and Professor Sérgio Oliveira from University of Pernambuco. I have organized this talk according to this outline. First, I'll give some motivation for the work, give some background. We're going to talk about the design parameters important to optimizing sensor devices for hydrogen detection based on the surface plasma resonance Quetman's configuration. And then I'm going to show some preliminary experimental results and draw some conclusions. I'm coordinating a project in Brazil in our laboratory directed to developing a sensor system for early fault detection of high voltage transformers. Let me just put here a little tool here. This is usually done by dissolved gas analysis when some malfunction starts to take place in the equipment. Generally, these equipment are insulated by mineral oil, and some specific gases start to appear dissolved in the mineral oil. For instance, corona effect give rise to those gases shown here. Thermal decomposition, the number of gases that can be found dissolved, and electric arc also. There are some minimum concentration requirements so that these markers are showing a certain amount of malfunction in the equipment. And for most of these gases, we have absorption spectroscopy with wavelength modulation techniques that enable you to detect those gases very efficiently. But hydrogen, because hydrogen doesn't have absorption lines in visible or near infrared, or where we have low-cost light sources and fibers, we cannot use those techniques for detecting hydrogen. So the scope here is to try to use a different approach. So the long-term objective of the project is to develop an online monitoring system for the solid gas in transformer oil, and with these features to be simple, to have a totally passive sensor head, and be amenable to remote sensing. This is the overall project. As part of this project, we are trying to develop this to obtain sensing of hydrogen by reflectometry under surface plasma resonance. In particular, the problem we are studying right now is surface plasma resonance in the Quetman configuration. Also, by doing this, our focus is to determine the thin film configuration, most adequate. Should we use a single layer, or a single sensitive layer, or a combination of layers to improve sensitivity? And also, once that is accomplished, what are the parameters or design parameters for maximum sensitivity? We use the fact that palladium is absorbs specifically hydrogen, different than other metals that they absorb non-specifically hydrogen, but palladium has a high specificity for absorbing hydrogen, and that's our transducer layer. And the idea is to use the questions configuration. So that's what we intend to do, and also use the simple question configuration that can provide a surface plasma resonance in the prism coupling question configuration for detecting the gas. So the issues we are interested in, should we use a single Palladium layer, as I pointed out before, or should we use a combination to improve the sensitivity of the device? For instance, we know that gold has a very good resonance, and Palladium doesn't have a resonance, as we are going to see in the next slide. And we thought that adding a gold underlayer would probably improve sensitivity. So that was one important question. And also, what's the most adequate wavelength and thickness of the structure? So these are experimental data measured by Rothke and Rubin in 1999, showing the degree of changing in refractive index and extinction coefficient of Palladium before and after exposure to 100% to a 100% atmosphere of hydrogen. So this curve is labeled PDH2, means that the surface was exposed to 100% hydrogen. So in general, the optical constants decrease mostly. I mean, not a little beyond 600 nanometers and beyond. Optical constants decrease. This is in principle expected because Palladium, as it absorbs hydrogen, the interspacing between atoms increase a little bit, about 3 to 4%, and that leads to a decrease in free electron concentration, let's say, in the material, because of the distance is increased between the volume increases, right? So decrease in concentration leads to a decrease in the refractive index because it's to first order is proportional to the concentration, and a decrease in the extinction coefficient. So that's what happens. So these are measurements obtained for a 10 nanometer thin Palladium film. So we have a region where there's a maximum change, but we have also to consider the specificity of the surface plasma resonance technique, the region of maximum sensitivity, combined with this thing here. So to give you an idea, I mean, we have to determine if should we use a single Palladium layer or a Palladium gold with gold underlayer. And this structure here, we thought that this could improve sensitivity because gold has a very sharp resonance throughout the visible infrared and infrared. Palladium has a very broad resonance. It doesn't even looks like a resonance, in fact, just absorption, as we can see in the next view graph. So the question is, should we use, what's the best solution here? To illustrate why we are asking this question, we just have plots here of a reflectance versus incidence angle in the question configuration. Okay, this is the question configuration here. Showing that for a single Palladium layer, you have a very broad resonance. This is the total internal reflection condition here, at this angle here, at this point. Then we have a large, broad resonance absorption for Palladium. As you add another layer of gold, and you increase the thickness of gold, you start to have a resonance that starts to resemble the gold resonance. Becomes sharper and sharper. So it would be conceivable in principle that adding, there might be an optimum thickness of gold, just looking at the resonance curves, that gives better sensitivity relative to a single Palladium layer.